To find the derivative of e to the x, we will use the limit definition of the derivative. The limit, as h approaches 0, of f of x plus h, which is e to the x plus h, minus f of x, which is e to the x, our function, all over h. Next, we will use an exponent property. E to the x plus h we can think of as e to the x times e to the h. When we have like bases, such as base e, and they're multiplied together, we could think of e to the x times e to the h as the property where we add our exponents. E to the x times e to the h is equal to e to the x plus h. We are using that exponent property in reverse. Looking at the numerator, each term has an e to the x in them. Let's factor out the e to the x. We will be left with e to the h minus 1. We'll need to write that all over h, but I'm going to divide the h over here on the right-hand side next to the terms with h in them. So we can take a closer look at this e to the x. Now as h is changing, as h is getting closer to 0, e to the x remains constant. So you can take a constant and pull that right in front of the limit. So we can write the e to the x out front multiplied by the limit of, as h is approaching 0, of e to the h minus 1 all over h. And now we need to take a closer look at this limit left here in the bracket. If you are familiar with L'Hopital's rule, you can apply that here perfectly. However, my students have not discussed L'Hopital's rule yet, so we are going to take a graphical approach. So we can analyze this limit by plugging in e to the h minus 1 over h into a graphing utility. So here's what we would have as a graphing utility version, but I had to plug it in as e to the x minus 1 over x, replacing the variable here. So we're treating h as if that is our new x value. So as h is approaching 0, it's as if our x values are approaching 0. So following along the curve, as x values get closer and closer to 0 from each direction, it looks like our y values are approaching 1. So the function values are getting closer to 1. Hence this limit is getting closer to 1. So we have that limit approaching 1, which is still multiplied by e to the x out front. And e to the x multiplied by 1 is equal to e to the x. Hence, what we've just established is that the derivative with respect to x of e to the x is equal to e to the x.